Hello friends, we'll solve now all 10 questions of 44th SSC CGL solution set of SureSolve.com. Topics are time and work, pipes and cisterns, and speed time distance. This is Attorney Chaudhary. The first question. A man and a boy can complete a work together in 24 days. If the man alone does the work for the last 6 days, then it is completed in 26 days. How long will the boy take to complete the work alone? Let portion of work done in a day by a man be M and a boy be B. These are their work rates per day. First time, both the man and the boy work together for 24 days to complete the job. So, 24M plus 24B equal to W, where W is the work amount. Second time, the man works alone for the last 6 days in a total 26 days to complete the job. So the boy works for the first 20 days and the man works for all 26 days. The work equation is 26M plus 20B equal to 24M plus 24B equal to W, or 2M equal to 4B. Substitute 4B for 2M in 24M plus 24B equal to W to get 72B equal to W. It means the boy will complete the work W in 72 days while working alone. Answer is option B, 72 days. Second question. Two men M1 and M2 can complete a piece of work in 12 days and 18 days respectively. M1 begins to do the work and they work alternately one at a time for 1 day each. When would the whole work be completed? Every 2 days working alternately with M1 starting first, M1 and M2 would complete a work portion of 1 by 12 plus 1 by 18 equal to 5 by 36. Working for 7 such couple of days, that is 14 days, would complete 7 times 5 by 36 equal to 35 by 36 portion of the whole work. This work amount we find to be just less than 36 portion of total work amount. In 8 times 2, that is 16 days, 8 times 5 equal to 40 portions of work done would have exceeded the boundary of 36 portion of total work. So 7 times 2 equal to 14 days is the maximum duration during which both M1 and M2 will work in alternate days to their full day work capacity. On the 15th day, only M1 will work to complete the remaining 136 portion of the work left. M1 does 112 portion of work in a day. So to complete 136 remaining portion of the work, he will take 12 by 36 equal to 1 by 3 days more. The work will be completed in a total number of 14 1 by 3 days. Answer option A, 14 1 by 3. Third question. There are 2 pumps to fill a tank with water. First pump can fill the empty tank in 8 hours while the second in 10 hours. If both the pumps are opened at the same time and kept open for 4 hours, how much portion of the tank would be filled up? First pump can fill the whole tank in 8 hours, so in 4 hours it will fill half the tank. The second pump filled the tank in 10 hours, so in 4 hours it will fill portion of the tank 4 by 10 equal to 2 by 5. Together they will fill up portion of the tank as the sum of these 2 portions filled up by the 2 pipes. 1 by 2 plus 2 by 5 equal to 9 by 10. Answer option D, 9 by 10. Fourth question. A boy and a girl together fill a cistern with water. The boy pours 4 liters of water every 3 minutes, while the girl pours 3 liters every 4 minutes. How much time will it take to fill 100 liters of water in the cistern? Ignoring the filling amounts, concentrate on the 2 durations 3 minutes and 4 minutes in which the boy and the girl take their respective filling up actions. Question is, what is the least time duration in which the 2 actions will coincide? It will simply be the LCM of the 2, that is 12 minutes. This is exactly like 2 bells chiming at 3 minute and 4 minute intervals, chiming together at every 12 minutes. In every 12 minutes, the boy will fill up 4 times 4 liters each, a total of 16 liters of water. and the girl will fill up 3 times 3, that is 9 liters of water. Together, a total of 25 liters of water. So to pour 4 times 25 equal to 100 liters of water, it would take 4 times 12 equal to 48 minutes. Answer is option D, 48 minutes. Fifth question. You arrive at your school 5 minutes late if you walk at a speed of 4 km per hour. But if you walk at a speed of 5 km per hour, you arrive 10 minutes before scheduled time. What is the distance between the school and your house? Let T be the scheduled time duration and D be the distance from the house to the school. So by the first statement, when you reach school 5 minutes or 1/12th of an hour late, walking at 4 km per hour, the speed time distance relation is 4 times T plus 1 by 12 equal to D, or 12T plus 1 equal to 3D. Similarly, in the second case, walking at 5 km per hour, when you cover the distance D and reach the school 10 minutes or 1/6th of an hour early, the speed time distance relation is 5 times T minus 1 by 6 equal to D, or 30T minus 5 equal to 60. To eliminate T, multiply the first equation by 5 by 2 to transform it to 30T plus 5 by 2 equal to 15D by 2. Now subtract the second equation from this transformed equation to eliminate T. Result is 15 by 2 equal to 3D by 2, or D equal to 5 km. Answer option C, 5. Sixth question. A train covers a distance of 10 km in 12 minutes. If its speed is decreased by 5 km per hour, find the time taken by it to cover the same distance. The train covers 10 km in 12 minutes or 1/5th of an hour. Its speed is then S equal to distance by time equal to 10 by 1 by 5 equal to 50 km per hour. Reduced by 5 km per hour, its speed becomes 45 km per hour. Time taken to cover 10 km at this speed is T equal to distance by speed equal to 10 km by 45 km per hour equal to 40 by 3 minutes. Answer option A, 40 by 3 minutes. Seventh question. Walking at 3/4 of his usual speed, a man covers a certain distance in 2 hours more than the time he takes to cover the same distance at his usual speed. Find the time taken by him to cover the distance at his usual speed. Assume S km per hour be the usual speed of the man and T be the time taken to cover the certain distance of D km at this usual speed. In the usual case, the distance D equal to speed into time equal to St. At 3/4 of his usual speed, distance D equal to 3s by 4 times T plus 2. Divide this second equation by the first. Result is 3 by 4 times T plus 2 equal to T, or 3T plus 6 equal to 4T, or T equal to 6 hours. Answer option D, 6 hours. Eighth question. In a river, the speed of the current is 5 km per hour. A motorboat goes 10 km upstream and back again to the starting point in 50 minutes. What is the speed of the motorboat in still water in km per hour? Let the motorboat speed in still water be v km per hour with current speed 5 km per hour. So upstream speed equal to v minus 5 km per hour and downstream speed equal to v plus 5 km per hour. Distance covered each way is 10 km. So the upstream journey time is 10 by v minus 5 hour and the downstream journey time is 10 by v plus 5 hour. Sum of the two is 50 minutes or 5/6 of an hour. Equating, you get 5 by 6 equal to 10 by v minus 5 plus 10 by v plus 5. Or 112 equal to 1 by v minus 5 plus 1 by v plus 5. Or v square minus 24v minus 25 equal to 0. The quadratic equation is factorized to v minus 25 times v plus 1 equal to 0. As v cannot be negative, v plus 1 equal to 0 is invalid. So v minus 25 equal to 0, that is Stillwater motorboat speed is v equal to 25 km per hour. Answer is option B, 25. Ninth question. A person travels 600 km by train at 80 km per hour, 800 km by ship at 40 km per hour, 500 km by aeroplane at 400 km per hour, and 100 km by car at 50 km per hour. What is the average speed over the entire distance? Over 4 sections of the trip, you have to find the total time taken and the total distance covered. Dividing total distance by total time, you would get the average speed. Train journey time for 600 km at 80 km per hour equal to 600 by 80 equal to 15 by 2 hours. Ship journey time for 800 km at 40 km per hour equal to 800 by 40 equal to 20 hours. Plane journey time for 500 km at 400 km per hour equal to 500 by 400 equal to 5 by 4 hour. And the car journey time for 100 km at 50 km per hour equal to 100 by 50 equal to 2 hours. Total time taken equal to 15 by 2 plus 20 plus 5 by 4 plus 2 equal to 123 by 4 hours. And the total distance covered equal to 600 plus 800 plus 500 plus 100 equal to 2000 km. So average speed equal to 2000 times 4 by 123 equal to 8000 by 123 equal to 65 5 by 123 km per hour. Answer option A, 65 5 by 123 km per hour. Last question. A man goes from Delhi to Agra at a uniform speed of 40 km per hour and comes back to Delhi at a uniform speed of 60 km per hour. What is his average speed in the whole journey? Assume the distance from Delhi to Agra to be d km. We will add the time taken in forward and return journey and divide the total distance covered 2d by this time taken. On forward journey, while going to Delhi, time taken was d by 40 hour. And on return journey, time taken was d by 60 hour. So total distance 2d was covered in 1 by 40 plus 1 by 60 times d equal to 5d by 120 equal to 2d by 48 hours. Divide the total distance travelled 2d by this time and you will get the average speed as 2d divided by 2d by 48 equal to 48 km per hour. Answer option B, 48 km per hour. To read the detailed solutions in text, please refer to the corresponding article in our website suresolve.com. The link is in the description of this video. And before signing off, please take a moment to subscribe to our channel for latest uploads. Thanks for watching.